opportunity today to speak about technology that help us to gain some deal with environmental challenges with less energy cost and less impact on the environment. Just give a very brief introduction to the organization which I represent today, the Qatar Environment and Energy Research Institute. It's part of the Qatar Foundation, which established in 2011, and it is basically address the water security and energy challenges that Qatar deals with as part of the 2030 Qatar National Vision. And currently, we are part of the Hamad bin Khalifah University, and personally, I am also a joint faculty teaching courses at the university. The projects we deal with, or the sectors we deal with, is water desalination and treatment, water quality reuse, aquifer recharge, and water conservation. And I'm introducing today this technology, which I think is well known worldwide, but the thing is, application on each site is a challenge because of the water quality, temperatures, all other issues. So how does this work? You know, ozone is basically when you put dielectric discharge into an oxygen molecule, you break it into two atoms. And the two atoms, become active. It attaches itself to another molecule of oxygen to make a new molecule, which is the O3, the ozone, which is a very unstable molecule. Because of that, it's very active, and the oxidation reaction is very fast. And this is basically happening in nature, which is when you see lightning happen, that's when ozone is produced, basically by, electricity with the oxygen. You break it exactly what we just showed. The real advantage here, if you see the cycle, since it's not very unstable, it breaks down to oxygen. So when we use it at the end of the day, any ozone left breaks to ozone. It's not like other chemicals that you have to get rid of, like chlorine and other chemicals. So that is one of the small parts of the green energy that you use, or green technology you use. And you see the level of introduction of the plants in the United States is growing very fast. And this is up to 2011, this diagram, but we have many more plants being produced, and same in Canada. And this is in Japan. Plants are produced for water and wastewater in addition to industrial applications, which is growing very fast due to some challenges that ozone proved to be working successfully against. Ozone has a very strong capability for disinfection, dealing with parasites like Cryptosporidium, Giardia. Cryptosporidium is a very lethal parasite that caused the death of 100 people in Milwaukee in 1993 in Wisconsin, United States. And Giardia is another parasite. Cryptosporidium, by the way, chlorine has no effect on that. That's why you need to look at other disinfectants. And viruses, those are the new challenges, or many challenges that not many laboratories can deal with them on a daily basis. So you have to have a technology that's proven can deal with it, because, for example, in Canada, United States, there are only few labs. In Qatar, you have to send samples outside the country to the Emirates for testing. Also, some of the industrial applications in oxidation, dealing with iron and manganese, especially in hydrogen sulfide, especially in groundwater. This is a big problem for facing the water industry, so can deal with that. MIB and geosmin, that's for taste and odor. Pesticides, which is going to be dealing with in the presentation. Color, and it's another problem. Algal toxins, that's a problem. It's facing the world, you see in the Great Lakes, United States, city of Toledo last year, they had 2 weeks. People could not use water tap because of the toxins in the water. Other locations in the Middle East, in the Arabian Gulf and Oman in 2008, they had the same problem. So it is growing. And then the endocrine disruptors and pharmaceutical, this is some of the new challenges. And sulfide ion oxidation is a very known oil industry face this problem. So the co-produced water, we deal with it with ozone to remove this issue. And also color. Whatever people tell you this water, if I bring you this bottle of water and the color is yellow, it doesn't matter how many certificates I give you, it's good, you won't drink it because it's aesthetically not acceptable. Same thing if it smells. Even people scientifically say has no issue because it's not poisonous. Still, you don't want to smell a water that smells to drink. And these things are important because when people start calling, I remember when I used to be in charge of the water department in the city in Canada, the first thing when people start to call is not because there are traces of pharmaceuticals in the water or trihalomethanes, and the water smells. And that's when people start to call. That's why you need to come with a technology that deal on daily basis, not only when the problem happens. And you see here the color of the water prior to ozonation and after, you can see the difference. Taste and odor, as I indicated, provided a very successful operation. And in fact, the city that I introduced ozone to, they received the best tasting water in Ontario in Canada for 2 years in the last for twice in 5 years, and which is a really good indication of the success of the ozone. So water, as I indicated, it doesn't matter how many certificates you have. If it doesn't taste good, if it smells bad, nobody would like to drink it. These are a good list of the advantages of ozone for drinking water and wastewater: powerful disinfectant, removal of pharmaceuticals, personal care products, taste and odor control, improved treatment process, reduced trihalomethanes, which are the carcinogens after you apply chlorine, elevated dissolved oxygen, which is really good for treated wastewater after it goes to the ecosystem, and it, as indicated, decomposes back to oxygen. This is a typical ozone. That's the ozone system that I was involved in building. And the city, this can produce 500 kilogram a day of ozone. And this is the liquid oxygen tank, and you have an ambient vaporizer to vaporize it, so you don't use any energy to vaporize that in order to prepare the gas necessary for the operation. And the improvement of operation, this is a good indication. We were looking at, we have monitors on the filtered water, and we looked at particles, and we made a particle distribution in micron size, 2 to 5 microns, which is the size of the cryptosporidium. So you have like a surrogate method to look at potential removal of these particles that mimics the size of these parasites. So 2 to 5, and you see here, prior to the ozonation and after the ozonation, and you see the size in particles and the 5 to 10, which is the giardia, and this is equivalent. So you see a good removal of particles. And the particles presence is an issue because viruses and other bacteria can attach itself to the particles. So the more you remove, this is a good log activation credit you get for your water treated. Also, we were able to achieve reduction of chemicals use. And during our test, we found this data that with the chemical we used during the test, during the 12 hours test, we see the turbidity, which is the amount of, shows the clarity of the water. At 0.06, it got better to 0.03 after the ozone use. When we shut down the ozone, it goes back to the same that. So that means you can achieve high quality at less chemicals. This data was published, in fact, in a book because it was a good achievement for the ozone industry after that. Also, you are able to reduce the backwash water. A very good example how to, like, you know, when you wash your filter, because you need to have your filter cleaned between one time and the other. If you have a swimming pool, it's very similar to a swimming pool. You have to backwash your filter to make it working efficiently. So here, we were able to extend the filter runtime. What does that mean? You reduce the amount of wastewater produced, you reduce the amount of pumps usage, so you reduce the energy in order to keep the operation going. We were able to achieve the total operation from 48 hours maximum for each filter to 72 hours. That means we reduced the energy use for the backwash pumps by about 50%. Why you need to look at these things? Because you are introducing a new technology. So would the new technology be increasing the energy use higher? But the thing is, with the chemical reduction, you subsidize into that. So the improvement of operation is indicated filter runtime, and this is a big issue for, you see the amount of backwash water. This is the amount compared to that one after. That means you don't have to send it to the centrifuge, so less centrifuge work in order to send the also less solid sent to the landfill. So, and you see here the percentages is being reduced from 2.7 to 2.1, the backwash water to the filter. Also chemical use, alum use was reduced, and the filter aid, the coagulant aid also was reduced. In fact, the funny thing, this was reduced by about 28%. The supplier called us after 2-3 months. They said, have you switched to other supplier? We said, no, we're using less. So he thought, because since we're not buying, he thought we switched to somebody else. The other thing, powder activated carbon, we used to use powder activated carbon for the taste and odor. And when you use powder activated carbon, basically, where does that end? It ends as a sludge. So you send it to the sludge and you pay the landfill to take it. So that's another problem. And if you have a toxin in the powder activated carbon, you're putting it in the landfill. When it rains, the toxin will leach into the water table. So that's a problem, and that is always when you use a powder activated carbon or a GAC, you're removing the problem from one side to the other. Power use, as I indicated, this was the power used. Even we used more water, there was a slight increase in power use, but we added a new technology. We looked at that. In fact, we evaluated if we use UV. That will be another 20% increase if we used UV. And in fact, we have a study after that showed that about, in fact, UV increased by about 30 to 40%, in fact. And you see here, this table show you the reduction in cost and the chemical use. The total reduction in operational cost in the year was $247,964. So close to $250,000 in operational cost we reduced. So it was a good achievement. Plus, you have a better quality of water. The adding of the ozone, in fact, was a must because we will not be able to provide a safe drinking water according to the regulations in the country. Another application is the use of ozone for laundry, and that's a good case study for industrial. And there was a study done by Mr. Rip Rice, who, God bless his soul, he passed away a few months ago. This guy, he is the founding member of the Ozone Association. And he did a major study on the industrial use, especially for the ozone and the laundry. And they found a major reduction of energy use due to the enhancement of the water quality used into that. And they found out that about 90% in washing and 20% in drying energy cost was achieved. And reduction of chemicals use, also less chemicals, exactly what we did in the drinking water. This one, less detergents being used. And also you have more oxygen in the wash water. Oxygen is better, it's an oxidizer in a way, even it's a weak oxidizer is better than less. And also, the ozone oxidizes the linens. And so you can use less wash water, a smaller water cycle compared to the other. Also can reduce the use of chemicals like with higher pH, especially for detergents. You have to use a high pH. And you see sewage treatment plants, the discharge has a lot of detergents, traces of detergents, and because of that. So we found a reduction into that. Also, as I indicated, a less water use, 30 to 45%. and also recovery for the water. You can also do a recycle and also reuse. Improvement of life and quality. The shorter cycle, that means you have less impact on the textiles. So it gives it longer life, especially linens for hotels. People use them, wash them every day. The effluent water quality, it means less BOD and COD because ozone oxidizes these compounds. So when you are sending it to the sewage treatment plants usually have a limit how much you can discharge of the BOD or COD into that they should receive. And if you put more, there will be a penalty. And again, since it decomposes to oxygen, that means you have less, you don't have to add another chemical to decompose it, like with the chlorine. You have to dechlorinate it if it goes out into the sewage. And this diagram will give you what the reduction, 21% about chemicals, water 26, 30% electrical, labor, and natural gas because of the energy used. The other advantages of using ozone, which is, I think, a key for the future applications of ozone, it is the presence of pharmaceuticals in water. The World Health Organization released a report last year, a study done on 114 countries, and they indicated that the next few decades will be what they call it the post-antibiotics era, because antibiotics is not effective anymore on many of the applications that used to be successful. Why is that? Because of these traces of pharmaceuticals in water, bacteria to develop immunity, and where they're coming from. A human body does not use all the antibiotics. This is a simple diagram. It shows that the application for urinary tract infection, E. coli causing that, it used to be dealt with by simple antibiotics. It's not working anymore, and there are many outbreaks in hospitals because of that. These pharmaceuticals, personal care products, where it come from? You get prescriptions. Also, people take a lot of vitamins, enhancements, whatever. Also, agriculture and veterinary use a lot. Now, many of these farms, the animal farms, they feed antibiotics in the water to prevent diseases to the animals. And also, they give them, some of them, give them hormones to grow faster. And you see now, some of the cows are huge in size. That's why some of the cows, barely can go into a truck when they move them into one side to the other. The chicken, if you go to the United States, the chicken is that size, almost each one. This is because of these growth of hormones and the chemicals they feed. Yeah, they make good money, but these compounds, the traces of these chemicals, are in the animals that we eat the meat from. So also, you need to reduce that, also the discharge. Some of that water goes where? Into the discharge, it goes to the water table, it goes to the lake, into the river. Also, we take a lot of shampoos and fragrances, herbal remedies, and where does that end? It ends into the lakes, into the rivers. The discharge from sewage treatment plants is the major source, and it's considered a giant collector for human waste. So this thing, we need to look at it. In part of my work on the Great Lakes, as the director of the Great Lakes Regional Office, we did a study to evaluate, a survey, how many sewage treatment plants discharged into the Great Lakes. 1,057 plants around the Great Lakes discharged into the Great Lakes. And you're talking about cities the size of Chicago, Toronto, Milwaukee, Detroit, all discharge into that. There are millions of gallons also from untreated sewage. When you have a heavy rain, it goes into the lakes. And you could say where it's coming from. If you see here, animal farm, household, and where does it go? Go to the water table, and you have here the sewage treatment plants, and it all end up where? Into the water. We have the fish, so you're eating this fish, you're drinking this water, And also people go swimming, so they might have an impact on them as on their skin. The United States has been looking into this issue seriously, and the endocrine disrupting compounds as chemicals that alter the hormone system and control the growth is becoming a key to the studies that's been done in the last 10, 15 years. And this is a very typical example how these endocrine disruptors, even they are small in nanograms per liter, they can mimic the compounds coming and to the receptor. So either it gives a signal to stop putting enzymes, or to give more enzymes to be added. And that is when you have hormone problems. And that's where the endocrine systems is becoming a problem. So why they are concerned? Because we have a continuous discharge into the Great Lakes and into the other lakes. Why I mentioned the Great Lakes? Because this is 20% of the world's fresh water. You have 40 million people around it discharging their activities into these lakes. You have other places, the sea. You have ships discharging their ballast water. You know, the ship travels for months in the water, and the water in the washrooms and all that, and from the food products, goes into the ballast. The ballast water there get discharged into the sea. And where these contaminants goes, where the other species could take it. Currently, there are studies to find out if there are any impact on human health. You need at least 20, 30 years of data to see an impact on your human health, because life cycle is long. However, the life cycle is short for other species, like fish. That's why a lot of studies were focused on fish to look at it, because you have a 1 to 2 years, an impact could make a good signal of what's happening. This is a study done, and you could show the shape of the male fish has been changing to look like a female fish. And also a growth of organs, female and male organs in the male fish. And that's what, in fact, scientifically is being called feminization of fish. This has been found in different parts of the world, in England, North America, and other parts. So it is a problem. What's the impact on human health? It's good to know within the next few years, because scientists around the world are collecting data to find out what is this problem. A study here we did on Detroit River, and Detroit River is one of the most polluted rivers in North America. And you see, we compared the conventional treatment to the ozone removal, and you see the removal capability in yellow bars compared to the other, which is almost no removal in some of them. And we looked at different parts of the year, because there is also the heavy rain, the different use, tourism, all these things. So that was a positive mark about the improvement of water quality. Also, we did a study on Lake Huron in North America, and we see these are the compounds. We found it in different times of the year. It was, in fact, October 2008, that part of the study. And we looked at removal. We used now with the ozone, we put a hydrogen peroxide, which we call the advanced oxidation process, to put hydroxyl radical, which is a stronger disinfectant as well, in addition to ozone. We found this is the capability of removal with the ozone compared to this with the conventional. And you see the percentages. However, at a very low concentration of ozone of about 2 milligrams per liter, we saw some restriction on some of the compounds. You see ibuprofen. We take a lot of ibuprofen ourselves. Ibuprofen is the Advil or others, compounds, the commercial name. The structure of the molecules dictates the reaction, because ozone will try to find which part of the molecule will attack, if there's a hydroxyl radical attached, or nitrogen, or others. So when you have a certain molecule structure, you might need to use a higher ozonation concentration. This study was received the best study published in 2009-2010 by the International Ozone Association. It was, in fact, the master study that I supervised with that university. In conclusion, ozone can provide us a lot of advantages, and that is financially, when you use a new technology, you need to see how many achievements and advantages you achieve, rather than using 3-4 technologies to achieve what one technology can provide. Reducing energy, reducing chemical use, and cost. This is a high capability that shows that ozone was able to provide in order to remove all these compounds. And as professionals, it's our duty to provide good quality of life to the public. What is the knowledge transfer is needed here is we talk about it more. Let more people know about it. Some people will say, like when we're talking about Qatar, nobody's using ozone there. So they said, how come nobody told us about it? Well, I said, we're telling you about it now. So the next step is who is going to invest in infrastructure improvement. You need to look at it here, how much you can achieve with a different technology compared to the other. I end up with my talk here, and I'm open to any questions. Thank you.